Okay guys, so today we're going to be looking at implicit differentiation. So I'm going to start by writing down the implicit functions. So these are the implicit functions that we're going to be dealing with. So it's d over dx into x squared, which is equals to 2x. What does this mean? It means that we have to derive this function with respect to 2x, and then the derivative of this is 2x. And then we have d over dy into y squared. Now they say we must differentiate this with respect to y. So it's going to be 2y. Right. Now, if they ask us to differentiate a function with respect to x, which is a function of y squared, how do we do that one? So the solution to this is going to be 2y. You differentiate this, and then you multiply it by dy over dx. And if they say differentiates differentiates a function with respect to to x, and then you're given the function of sine y, then the derivative of this will be, derivative of sine y is cos y, then you multiply by dy over dx. Right. And then if, let's say, they're giving us to differentiate a function with respect to x, function of x times y. Right. So remember, for implicit differentiation, you need to also take into consideration the chain rule, the product rule, and quotient rule, because they still apply to this section. So if we look at this function is a product function. So it's we can only use a product rule to differentiate this. So we have x times y. These are two functions multiplying each other. So we use what we call the product rule. So it says, if I'm giving this function, it's going to be x times the derivative of this. So the derivative of y with respect to x will be into 1. The derivative of y is 1 times dy over dx plus y. Now we bring back y and differentiating x in terms of x. Then the derivative of x is 1, right? And then from here you can just simplify. So we have x dy over dx plus y. That's the answer, right? So these are the functions of implicit. Let's look at the examples and see if we are able to apply the functions given above. So let's see. Example 1. So they say find dy over dx when you're given 5y squared plus sine y equals to x squared plus ln y. Right. So we need to differentiate this with respect to x. So differentiating 5y squared with respect to x is going to be 10y. We first differentiate this 10y, but since we're differentiating it with respect to x, we multiply by dy over dx plus, this is sine y. We need to differentiate with respect to x, so the derivative of sine y is cos y times dy over dx equals to, then we differentiate x squared with respect to x. Derivative of x squared will be 2x. Right. Plus ln y. We need to find the derivative of ln y with respect to x. So ln y, the derivative of ln y is 1 over y times dy over dx. The reason why we multiply these terms with dy over dx is because they do not have x in them. So the only way to derive them with respect to x is that we derive and then we multiply by dy over dx to indicate that we are differentiating with respect to x. And then from here, we need to have all the like terms on the same side. So we transpose 1 over y dy dx over, on the other side. So each time you transpose, the sign changes. So we have 10y dy over dx plus cos y dy over dx. Then you transpose, it's going to be minus 1 over y dy over dx equals to 2x. Right, then from here we take out the common factor. In this case it is dy over dx into 10y plus cos y minus 1 over y close brackets equals to 2x. Now the aim is to find dy over dx. So we divide both sides by into 10y plus cos y minus 1 over y. What we do on this side, we do on the other side. So we divide also this side by 10y plus cos y minus 1 over y. Right, now this will cancel out. Sorry, this cancels this out. Then we're left with dy over dx equals to 2x all over 10y plus cos y minus 1 over y as the answer. So that's how you differentiate using implicit differentiation and its functions. Right. So next we're going to be looking at the second example. Number 2. So number 2 says, find dy over dx when you are given x squared minus 2xy squared plus y squared is equals to 3. Right, we differentiate with respect to x. Right, so the derivative of x squared with respect to x is going to be 2x minus, we can just leave the 2 out, then let me say into. Now when we look at x and y squared, this is a product rule. So a product rule says you differentiate you bring down the first function and differentiates the other one, then plus you differentiates the other one, and then you bring back the other one. So in this case we're going to have x times the derivative of y squared with respect to x is going to be 2y times dy over dx plus, now we have to differentiate x. So when you differentiate x in terms of x is going to be 1, and then we bring back y squared, close brackets, plus, now we differentiate this with respect to x. So it's going to be 2y times dy over dx equals to, now the derivative of a constant is always 0. Right. Then from here we have to simplify out. So we're going to have 2x minus this times all of this will give us minus 4xy times dy over dx, minus 2 times this will be minus minus 2y squared plus 2y dy over dx equals to 0. Then we transpose all the terms without dy over dx to the other side of the equal sign. So on this side we're going to be left with minus 4xy dy over dx plus 2y dy over dx equals to, transpose this one to the other side, it's going to be 2y squared positive, then we transpose this minus 2x. Then from here we take out the common factor. So in this case our common factor, it's dy over dx into, we can write it as minus 4xy plus 2y close bracket equals 2y squared minus 2x. Then we can divide both sides by minus 4xy plus 2y minus 4xy plus 2y. Then this cancels out. Therefore, dy over dx is equals to 2y squared minus 2x, all over minus 4xy plus 2y as the answer. Right, I hope you understand and see how do we go about solving this. Right, now I'm going to do a third example, still on implicit differentiation. Number 3, we're given y to the power xy is equals to cos squared x plus sine y. So we need to now differentiate this in terms of x. Find dy over dx. So now we need to differentiate e to the power xy. So when we look at xy, x times y, this is a product rule. So whenever we differentiate here, it's going to be a product rule. Right. Oh, let's just write this in simple form first, and then we can differentiate. We can just simplify this part. So we have e to the power xy is equals to into cos x all squared plus sine y. Then from here we can differentiate. So let's differentiate e to the power xy with respect to x. So we're going to have e to the power xy times into, we differentiate this. So it's going to be x times into 1 dy over dx plus differentiate x, it's going to be y, 1 times y. Right, close bracket, equals to. Now we differentiate the other side of the equal sign. So according to chain rule, it says that if you're given a function like this one, right, what you do is you first you drop this one down, the exponent, and you subtract 1, and then you differentiate what is inside the brackets. So in this case, we're going to have 2 into cos x times the derivative of cos is negative sine x with respect to x, then plus the derivative of sine with respect to x will be cos y times dy over dx. Right, then from here we can always multiply out. Right, so this times this will give us e to the power xy times x dy over dx plus e to the power xy y equals to, this times that will give us negative 2 cos x times sine x plus cos y dy over dx. Right, and then from here we bring like terms together, so we have to transpose whatever that has dy over dx to the left hand side, and anything that does not have dy dx to the other side. So we take this to the side, so we're going to have e to the power xy times x dy over dx. Transpose this, so it's going to be minus cos y dy over dx equals to negative 2 cos x times sine x minus e to the power x y times y. So we take out the common factor here, so it's dy over dx equals to, I'm sorry, into brackets, this is brackets, so we're gonna have, we can write it as x times e to the power xy and minus cos y equals to negative 2 cos x times sine x minus y e to the power xy. Right, then from here we divide both sides by x times e to the power xy minus cos y, close brackets, divide on the other side, so it's x times e to the power xy minus cos y. Now this will cancel this out, therefore our dy in this case over dx is equals to negative 2 cos x times sine x minus y e to the power xy all over x e to the power xy minus cos y. Right, as the answer. Right, So that's how you go about simplifying this. You need to take into consideration your product rule, your chain rule, and your quotient rule. Right. Gonna look at, I think, the last example. Right. So example 4 says, find the slope of the tangent to the curve. It says, find the slope of the tangent to the curve. Then we have x squared plus y squared minus 2x minus 6y plus 5 is equals to 0 at a point, or at the point 3 is to 2. Now, we remember from previous levels, if they say find the slope, the slope is the same as the gradient. So we know that slope is the gradient. So in differentiation, the gradient is dy over dx, or the slope is dy over dx. So we need to first find dy over dx for this function equation. Then from there we calculate the value of the gradient or the slope. So in this case, we need to differentiate x squared with respect to x. So it's going to be 2x plus. Then we differentiate y squared with respect to x. So it's going to be 2y times dy over dx minus. Then we differentiate this with respect to x. It's 2 minus. Differentiate this with respect to x. It's going to be minus 6 times dy over dx plus the derivative of a constant is 0. Derivative of constants is just 0. Right, and then from here, we transpose whatever that does not have dy over dx to the right-hand side of the equal sign. Then we have 2y dy over dx minus 6 dy over dx equals to, we transpose, so we're going to have 2 minus 2x. Then we take out the common factor, dy over dx into 2y minus 6, close bracket, equals to 2 minus 2x. From here, we divide by 2y minus 6, 2y minus 6. Then this cancels out, therefore, dy over dx is equals to 2 minus 2x over 2y minus 6. Right. So this is our dy over dx, which is also equals to m for the slope or the gradient. Right. But remember, we given the point 3 is to 2. We need to now evaluate or find the actual value of the slope when we have our gradient or our derivative is 2 minus 2x all over 2y minus 6. So now where there is x, we substitute 3, and where there is y, we substitute 2. So this is the x coordinate and this is the y coordinate. So substitution, therefore, m is equals to dy over dx equals to 2 minus 2 into 3, close bracket, 2 into 2 minus 6. So this will be 2 minus 6 over 4 minus 6. So this gives us minus 4 over minus 2. So this gives us positive 2 as the gradient. So that's how you go about finding the gradient or the slope of the tangent when given an expression and a point. Right. Thank you so much. This is the end of implicit differentiation.